Hello everyone. Today I'm on bed, by the way. So today our goal is to solve this 17 problems of array. One noted this is actually taken from Striver, but I have forged a bit. There are pretty some topics that I have added, so you can find it. I'll attach the link. I'm attaching the link. Let's just okay. So yeah, there we go. But why my background is a bit skippy? Now this is looking nice, but probably I should position myself at here, maybe. Yeah, now this is right. Alright, so I am using one notebook and I will use this application. You can find the name is Rnote. It's basically a Linux application. You can take notes and do some whiteboard stuff. So yeah, what we will do, we will start the root, the better and optimal solution of each and every problem. So we are today on array E. So yeah, the first problem, there some of them are geeks for geeks, some of them are lead code, some of them are Nokri or the code 365. There is, I don't really recall the name. By the way, yeah, I am on this account. Okay, so let me quickly create, because before starting I should be clear that I will run the code locally, try to understand it, then I will do submit on code the compilers. Okay, I will use C++, want to be noted. So yeah, so let me go to desktop C. Yeah, well, there is basics, then UI. Because I don't want to lose my YT file, so yes, to see array ECD, and I will do gvim largest. So I will create a couple of things like vi input .txt and vi, not just touch it, output txt, and so next I will open the input and I will give the input. So basically this is, I'll give the array, so 1 8 this one, 19, but before 1 2 3 4 5 all right. I'll use gvim because I like the interface of gvim. Let me do, okay, so it is saying what okay, given an array ARR, the task is to find the largest element in it and return it. Okay, it is easy though. So let me write the boilerplate. Okay, so should I make it a bit more big? What is the, how to be it? Can I edit tool, syntax, file? How to increase the size? Settings window. Tools. Can I just Control Shift P, Control Shift plus? No. So yeah, try to understand it. By the way, I will write the code over the compiler. So I am using bits /stdc ++ using namespace standard int main. So at first get the size cn, then take the value for int I equal to 0, I less than n, I plus C array of I, get the array int n, or take a vector of those. Anything can be done. Vector int arr n, anything can be done. And here find the largest equal to, is it int? Yes, it is int largest. We will just, so I'll just lg equal to largest of array. Should I give n? No. And yeah, that's the code should look like. But a couple of things that I think I should change is with the input, it should be 6. Okay, now what it should do, it's pretty easy. So there should be only one solution, so the code is look like oops, okay, 187 5690. I have to return the largest element. Now what is the way to do it? The brute force approach, the first solution that comes in my mind is doing a sort. Why? When we make a sort in ascending order, that time the small elements will stay on the first place and the largest will stay on the last place, right? So it should be sorted like 1 7 8 56 90. And if I return this, I mean the array of n-1, I can say ki this is the largest element in the array. So what should be the code look like? There should be not any what I'll say, any space, because I am doing in place. So I am doing sort. Now there's a function in stdc, the stl, the standard template library in C++, but we can do any sorting. If I consider quick sort, the time complexity is big of n log n, there is no space I mean extra space. If I consider a merge sort, there should be n log n and the space should be n, big of n, I mean extra space, as I require to reorder the sorting elements. So just consider big O of n log n. So what else should I sort the array? I get this and I just return a of n-1. So the complexity should be, I can ignore this because it is doing constant, so it is n log n. So let me do it in gvim, or should I? Maybe. So int largest, it will take the vector int and %. I'm getting the references of array. I'm thinking it is easy, so let's do it on the compiler, but I think we should actually know that how actually the compilation process does work. So what I'm getting, so int n equal to arr dot size, then I will sort it. How to sort the vector? So there is array dot begin. How do you mean array dot begin? The first, I mean if I consider C 1 8 7, then it should be begin, this should be end. What do we mean by that begins and end? What's the plus point of doing it, or what is the procedure of doing it? I'm starting the sort process from the here, and I'll end from here, end at here. Okay, so array dot end. All right, I will return array of n minus 1. I can easily get it. Okay. G++ largest.cpp dash o largest. Is there any bug? No. Dot slash largest, take the input, get return output. Okay, yeah, I'm getting 90. So let's do it on the code compiler. What I'm doing is I am doing sort. So at first get the n, to int n equal to array dot size, then I will sort what I'll sort is array dot begin and array dot end, and I will return array of n minus 1. Yeah, it do submit, but the complexity is a bit high, because it is big of n log n. I mean, what do you mean by n log n? It is big of n into big of log n. Can we reduce the complexity a bit? Yes, we can. Oh, point to be noted, if you think why it is log n, so if I consider merge sort or quick sort or any sort of sorting algorithm, so what do take place? This is the array, we break in some splitted site, we split it like this, then for like it will be like n by 2, n by 4, n by 2, n by 4. So it is divides. So this procedure actually, when you see this, that will log 2 base n. So yeah, that's the rule. Okay, let me remove the page. Is there any easy way to do it? Remove everything. Can I control A and delete it? No, I cannot. So okay, now the question comes, can we reduce the complexity? The answer is yes, we can. We can do it in the optimal solution. So how to do it? Let's consider I have 1 8 7 56 90. So can I say key go from this, start from this, I mean iterate throughout the array and see that does this element is greater than this. I am telling key go from first to last and check if that element is greater than the adjacent. What do I mean by that? Starting from 1, so let's take an imaginary largest, that will be 1, allegedly array of 0. So check if largest is greater than array of 0, or if you start from array of 0, start doing array of 1. No, it is not. So 1 is not greater than 8, so do replace 1 with 8. Then does 7 greater than 8? No, it is not. Okay, it is not, so don't replace largest. Does it does 56 greater than 8? Yes it is. Okay, so replace 56. Now does 90 greater than 56? Yes it is, so replace 90. So what I am doing nothing, just a for loop. It will be starting from I to n, and if largest is greater than or allegedly less than array of I, it will start from 1 to n, then replace like largest equal to array of I. We'll discuss the complexity later. I don't think that we should do submit everything on the compiler, because let's see. Okay, because it's just a hectic job. Okay, so for int I equal to 1, I goes to n and I plus plus, if largest is smaller than array of I, largest is array of I, and return largest, and obviously the int equal to array of 0. Now I think I want to say something. We should do it maybe after this. Yeah, it did submit. Now if you think that where should I put the largest, because there are some problems where you have to be a bit patient, that what should be the largest, should not we just do it 0 or 1 or a random value, but what if the array does consists -1 or -2 or some minus some big minus negative number? So that time I cannot really get that value. So it should be very good or efficient way to just get a real life value of the array. Okay, instead of getting int min or int max, I think this is the easiest way to do it. So what is the complexity? The complexity is big O of n, because I am iterating throughout the loop, so it will be big O of n, no extra spaces, big O of n. So and big O of 1 will be the space, and it will be the time. Now a question that comes, that I am starting from 1, I am not starting from 0, but actually you are doing 8 previously, you just mentioning, so just ignore that 1 2, just constant value. Actually it is throughout iterating, so it will be big of n. Nice, this is done, and I think probably that's the optimal one. Now the second largest element in an array without sorting. So they are saying ki you should not do it with sorting, but we will do it a bit sorting, because let's make it a bit interesting. Okay, how to remove everything, man? How does simple curved stroke dot position, select, okay, and select though, right? Okay, I can just delete it. Okay, now I got it. So now the question that says that, what does it say? Given an array of positive integers array, okay, there is a thing I'm getting positive integers. Okay, return the second largest element from the array. If the second largest element doesn't exist, return -1. Note the second largest element should not be equal to the largest element. Nice. So input array 12 13 35 1 10 13 34 1. So 35 is the largest, so 34 is the second largest. So if it is 0 10 10 10 10 -1, the largest number is 10 and the second largest doesn't exist, so it is minus 1. Okay, so what does it say? It is saying let me take that example. 1235 12, okay, just do it here. 12 35 1 10 34 1. Okay, now what if we have a sorted option? So you will start from boot better and optimal point to be noted. So the first thing when I get the largest smallest thing comes in my mind is sorting. So what if we just sort it? What I'll get? I get 1, I get 1, I get 10, I get 12, I get 34, I get 35. Now if I return n minus 2 because n minus 1 is the largest, then that easily be solved. But does it? I don't know why. That's the edge case. What the edge case? The edge case is, let's say I have 1 1 10 12 34 35 35 35. I can have multiple values, but for that can 35 be the largest? Second largest? Not at all. So what I can do is, I know that n minus 1 is always the largest, right? So I can ignore this. After sorting, I start a loop from n minus 2 to 0 and check if array of I is not equal to the largest. That is actually the largest, sorry, second largest, because if I am starting from here, whenever the first number that comes that is not equal to 35, that should be. So this is actually a nice way. Let me do it. So I'm going to array dot size for, okay, let me short it out. Sort array dot begin and array dot end. So for int I equal to n minus 2, I will go till 0, I minus minus. If array of I is not equal to largest, second largest equal to array of I, and return second largest. What I should do is, after that, int largest equal to array of n minus 1, int second largest equal to 0. Let me do it. I got a bug. Why? Okay, it is array of n minus 1. I'm sorting it. And I should be n minus 2, it will go till 0, and return why I'm getting 1. That's maybe because of no, but it should be in the answering sort. I'm doing sort. Second letter is 0. If array of I is not okay, I'm gonna start from n minus 1. Okay, I'm starting from n minus 1, and so the largest element is if there is no to extend it. So after sorting this, I'm getting 1 1 10 12 35 sorry 34 35. I'm just getting this after the sorting. So now how the loop is being started, it is starting from n minus 2 to 0. Does it equal to? No. Then go to I minus minus. It is going I minus minus. So what is the problem? What is the problem? I'm going to n minus 2, that is if I consider 6 minus 2 4 4 2 0. If array of I mean array of 4 is not equal to the largest is 35, so yeah, it should run. Let me see, just a second, let me take a note. And I'm doing correct. What is actually doing it? Alright, I'm getting this. So I have to just break it. When I'm getting it, I should break it. That's the point. Sorry. Not this should run. Yeah. So what was happening? Let me tell you what was happening. So the first time it get 34, next time it is getting, so it is running throughout it. Now it is running throughout it, it is getting this, so it doesn't care. At last when it get 1, then it return. So that's the case. Yeah. But is it the optimal one? Sorry, it is not, because it have a big O of n log n. Then so what is the sorting take? The sorting take big O of n log n, and then this is taking big O of near about n. So big O of n. So the total complexity is big O of n into n log n, and the space is though big of extra space is nodes extra space, but can we reduce it, because big of n into n log n is a bit high time. So can we do it? Let me think. thing that I have done with the largest number, I mean I'm iterating throughout it. I'm trying to find key, are you largest, are you largest, are you largest. Can we do the same type of approach with this? Like I have like 1, 9, 34, 35, 1, 35, 24. I'm taking a big number. What I'll do is I'll check. Let's say this is largest and this is second largest. So what I'll do is I is here, I mean the largest is here. I will say ki 9 are you larger than 1. I am saying 9 are you larger than 1. It will say yes I am. So I will replace L with 9, and when this is not largest, for this case, for 1 and 9, this case 9 should be largest and this should be second largest. So the thing that is not largest, that should be second largest. So this should be second largest and this is largest. So the second largest is 1. Now 9, are you larger than 34? No, I am not. So this will be largest, this will be second largest. So 34 is largest and 9 is second largest. Again 35, are you larger than 34? Yes I am. Okay, so 35 and 34. Are you? No, I am not. Okay, are you? No, I am not. Are you? No, I am not. So the 34 is the second largest. Now there's a question. What if I got, let's say this is 33, this is 33, and I got here 34. That time when I'm here, I am not greater than largest, but it is greater than second largest. So I will skip it and store second largest at this. Isn't that simple? What I will do, and so what should this look like? So I will see while the I should not do a while. I will start from a for loop, maybe for I want to n. I will say key this is the largest, this is the second largest, and I will just skip it. Let me do it. So int n equal to array dot size for int I equal to 0, I goes to n, I plus plus, and do some pb stuff. Okay, so int largest equal to array of 0. Okay, int second largest equal to 0 for now, and return second largest. Okay, so I will do if array of I is greater than largest, if array of I is greater than largest, if so largest equal to array of I, and before that second largest equal to largest. Now if, or do else if, array of I is less than largest, and array of I is greater than second largest. Second largest will be array of I. Probably this is all. Yeah. Okay, I'm getting possibly your code doesn't work to the multiple test cases. -1. Oh, for this case, right? 0 0 0 and all. Maybe we can just exit and return -1. Is this? So I can do if second largest is there, I mean a valid number, I will return, else return -1. And this will solve it. Yeah, it's solved. So this is the, I don't really know that how to resolve it. I know there should be some way to do it, but yeah, I don't really know how to resolve it. Isn't it doing ternary operator can be a way, but yeah, we just patched something. Okay, we don't have anyone right now. We had someone, but right now we don't have. Okay, all right folks, we did it. Now what should be the time complexity? The time complexity is big O of n is it, there is only one for loop, so this is big O of n, no space. But can we reduce it? Let me see. No, there is no optimal solution. So I have a notebook. In the notebook I have written this is brute, this is better, this is optimal, and this is the problems. This has a brute, this has a optimal, this don't have a better, this has a brute, better, optimal. So I try to understand, because sometimes, to be honest, when you go to interviews, so personally for my case, I know I've been dumb, so basically I just remember the optimal one, I don't recall the brute sometimes, but sometimes I recall brute, not optimal, sometimes I recall better, not optimal, not brute. So try to get some quack in my mind that what should be the brute and not what should be the brute. Is there any brute optimal better approach, or just an optimal, just a brute, just a stuff. Okay, so this dirt, but okay, attempts total correct. All right, so probably I have did some sneaky peeky stuff. That's the reason why I'm getting so many accuracy. Alright, so what is the okay, so the next thing is I did two. That's the second largest and the second smallest number and array without sorting. This is nice. This seems to be nice. I have to get the second smallest and second largest. Same for the second smallest. So I should create something like int. So I have to return, right, this return second, so like this, int second smallest equal to get second smallest. I'll get array, not I'll get in and a and int second largest in and a. I will return second smallest and second largest, like this. So what is the first is okay, first is second largest. So just it doesn't matter, just I'm doing a bit nice style. Okay, so int second largest, it will get n, it will get vector int a, like this. So int n equal to a dot size for int I equal to 0, I less than n, I plus plus, if so the second largest, the same thing that I've did, right? So yeah, no need to just tell you the second largest, but I should I should make you understand the second smallest. Okay, so int largest largest equal to a of 0, int second largest, or I just sl and do this as a l, sl equal to 0 for now. If largest is smaller than array of I, then l equal to a of I. Before that, l equal to sl. Now just remember this, don't name the functions like variables like l and sl. Give a nice number like second underscore largest, because I will not stop this. Okay, now if, or I can do more efficiently, else if the largest, if the array of I is smaller than, or more efficiently not equal to, because let's say I have 35, so that is not smaller, but that is even equal, so I will not do it. So if it is not equal to largest, but it is not equal to largest and largest and array of I is greater than second largest, what I will do is I will say key second largest will be a of I, not array of I, this. Okay. And I will say return second largest. Now for the second smallest, everything remains equal. Everything remains equal. What gonna changed? It will say largest. Any variable name change? Okay, so smallest second smallest. Okay, if L is smaller than this, then smallest is LLEST or LEST, I don't know, will be second smallest and smallest will be this. If it is not equal to smallest and it is less than second smallest, second smallest, return second smallest, and the function should be second get second smallest. Let me run it and see that it does work or not. Okay, it does some compilation value fatigue. Oops, so I have already an X. Where is the L? Oh, sorry. I did these mistakes again and just this will ruin my interview once I just believe it. Again adding control F error. I just oops, there should be get wrong answer. Okay, nice. 2 and 0 both are wrong. Okay, we will see. Okay, if n of I is not equal to largest, or it is less than it should be, and it should be greater. What if this? Alright, if it is 0 I should be 0 to n, largest is less than, or more specifically, if E of I is greater than largest, then the second largest will be the largest and the largest will be array of I. Okay, else if array of I is less than largest but it is greater than the second largest will be swapped. But this should be checked like this. It is greater than largest. shouldn't we do it int max and if array of I is greater than largest, then largest will be second array of I. Else if it is less than largest and array of I is greater than second largest, then second will be array of I. Second largest. What's wrong here, man? It is written that is non-negative value. Yeah, probably this one makes us trouble. If array of I, let's say I have 1 1, it is greater than the smallest but less than the second smallest. But greater than, okay, let's say I have 1 1 2 2 1. So if I just seconds, I'm getting the this is 3 and 2. Yeah, this is looking nice. What is wrong? Let me just do a Google. I'm still getting in trouble. Why is this possible? What's wrong? Oops, my bad. Yeah, I get it wrong too. My bad. I did this mistake. And this you can do it as array of 0. I mean, you can do it 0 because I don't have. Oops. Just reduce it. My bad. Okay, so what is the next? Okay, so it should not. Oh, no, it is my bad. Yeah, I have did it correct. It should submit probably. No. The fuck. It's giving wrong answer at this. Probably I am doing some notes wrong here for second till smallest. Yeah, it is getting wrong for every cases, even though mine. I get it. You know why this is possible? Because I now get it. Because say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. When I am keeping the smallest array of 0, so it stays at 1 and 1 is less than everyone. So I cannot update the second largest remains 0. This is the reason why. So what I can do is either I can take an int maximum value. Yeah, I totally get why. This is a nice one. Thanks ChatGPT, by the way, for for this fix that I mistakenly did. All right, nice. By the way, I should do a thing key when I click on, then a new tab will open after the links. But yeah, check an array is sorted. Okay, by the way, what is the complexity? We have decided that this is big of n for each. So if I consider the whole program, that will be big of n into big of n, and if I consider every program separately, that will be big of n in each case, and the complexity, there is no extra space, so that will be big of 1. So this one I have done. Then check an array is sorted. Three problem. Nice. Point to be noted, I am trying to take maximum time while solving this problem, because I can code just silently, just do it first, but I'm trying to understand it everything, right? Okay, I have to say you have been given an array A of n non-negative integers. Okay, non-negative, you have to check whether the given array is sorted in a non-decreasing order or not. Your task is to return 1. If it is sorted, other 0. Okay. So for example, I have 1, 2, 3, 4, 5. I have 1, so this is sorted. So how to do it? What is the brute force, by the way? Is there any? So I have 1, 2, 3, 4, 5. Is there any brute force, by the way? What I can do is Hmm. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, I can do is if it is sorted. Is there any brute, by the way? No, there is nothing. What I will do is I'm trying to find a brute, to be honest. I got the optimal solution in my mind, but I'm trying to find the brute, if there is any. One thing can be done. Copy this whole array in a vector, sort the vector. If this is equal to this, that time it can be called as a sorted. Let's say I have 1 2 3 4 5. I have copied this instead of a vector 1 2 3 4 5, and the reverse is obviously, sorry, reverse not, sorting is obviously this, so I have to equal that. If array of I of array of, this is, let's say, A, this is B, or more conveniently if I wanna name them, so this is original, this is reverse. So if originals I is equal to reversed I, then I plus plus. If it is returns yes, then no. It can be done, right? Let me do it. Or instead I can store everything in a hash map, but can it be? Yeah, it can be. So what I can do is vector int copy num, this size will be n, to for int I equal to 0, I goes to n, I plus plus, see copy num dot push back of a of I, and sort copy num dot begin copy num dot end, if then for int or while I is less than n and I equal to 0, if copy num of I is equal to a of I, if it is I plus plus, else return false, or return what, 0, if it does return 1. Let me see it did succeed or not. Let me do it and see what's wrong. What's wrong here? Sorry for this, by the way. What's wrong? Yeah, okay, all right. Okay, I have to use it, by the way. So please. Fast. Why am I okay? Okay, I'm getting 0000, then 17 everything. And I used 0. Why this? Why this? If I don't, what's now? Yeah, that was the problem. That was creating some extra spaces. So it was the old one. Now Can we optimize this? Yes, obviously this is big O of n. For inserting in a vector big O of n, sorting big O of n log n, this is another big O of n. I mean, I'm considering the worst case, so big O of n, big O of n log n, big O of n, and the space, if big O of n is the size of the element I will put inside of the vector. Obviously this is not the brute force solution, this is not the optimal one. We can do it within a big O of n loop that we will talk about the optimal. What I will do is, this is the most to be honest, in my notebook where I've written the brute better optimal yes no or something, there is nothing called optimal. I actually thought it with some times to tell you. Now the easiest one is to do, there is an I pointer, check if I plus 1 is greater than I, if it is move I. So what I'm talking about is, let's say 1 2 3 4 5, put I here. Is I less than I plus 1? Yes brother, it is. Okay, move I a bit. Now yes it is, move I a bit. Yes it is, move I a bit. Yes it is, move I a bit. So I can do int I equal to 0 for while I is less than n. If a of I is, array of I is less than array of I plus 1, then I plus plus, else return minus 1 or return 0 maybe, right? What? Yeah, return 0, return 1. Oops, same bug. Less than or equal to maybe, right? Array of I. What if I do greater equal, oops, control Z, greater equal to I minus 1, the same concept. Yeah, so this is the same concept. Why I minus 1 not I plus 1? I am doing let's say 1 2 3 4 5. I is here, I should start from here. That was the problem that was occurring at the time. Check I minus 1, check I minus 1, check I minus 1, because when I do I plus 1, I am here. Next I am also checking with this. That's the problem. So yeah, now can we do while, can we do a for loop? The answer is also yes. How to do it? Simple. For int I equal to, tell me what it should be. It should be 1 to n. So if a of I is greater or equal to a of I minus 1, return, do nothing, just do nothing here. See here, do nothing. Or can we do this? Else return 0, return 1. Can I do? Yeah. Yes. I think we cannot do this, right? Yeah, we can do it. I don't know what the problem in Naukri when I just save it though. Yeah. So can I do this? I'm not quite sure. Yeah, we can. See, now this time it did go on. This time did go. Oops. Okay. 4 is done. Check an array is sorted and rotated. Where is my phone, by the way? I should see the views. There is my phone. It's like a hot chimney. Holy shit. How hot this is, man. I think it should not burst just. Let's give it a charge. It's just as hot. My bad, my bad. Please don't go off. Please don't go off. Is it running? Is it running? Is it running? Yeah, it is running. Alright. Let me see how much people are actually watching. Okay. Nice. Okay. Check an array is sorted or not. I should swap to C++. Oops. Sorry, I did it. My bad. Okay, check is if the array is sorted and rotated. Why? What is the case? Let me just select everything and delete. It is 3 4 5 1 2. Okay, 3 4 5 1 2. Nice. It is true because 1 2 3 is sorted out. You can rotate that x equals to 3, so the position becomes okay 1 2 3. If I just rotate this, alright, but I will get it is true because if I rotate this in this position, now I know that there are so many ways to do it. There is sliding window procedure, but I know there is an optimal approach, and I don't recall the route. What is the trick? You know what is the trick? It's a cool trick that, to be honest, I got from a solution. I don't really know who actually gave the solution. I really don't know. Probably this guy. No, not at all. So let me tell you what is the problem is. The problem is, sorry, the solution is I have to check how many time the sorted order fails. Do you get it? Let's understand this. 1 3 4 5 1 2. How many times the sorted order got failed? So 3 4 5 it is done. Then it is 1. So 1 time. So I will count equal to 1 1 2. It returns if count or more allegedly the occurrence, how many times the sorted order fails, is less equal to 1 or it is zeros or 1, that time I can say that it is, yes, it is sorted and rotated. Now let's say I will take an example of when it is false. 2 1 3 4 2 1 3 4. How many times the sorted order got failed? 2 1 1 time, 1 3 1 3. Oh, there is another case. Understand this. Locate the first digit and the last digit. The first digit, if first is less than last, increase count. Why? When you rotate something, the general look of a sorted list is something what, let's say x, some value y, obviously x is less than y. But if I rotate it, it should not be like this, na? So when x is less than y, I will increase the counter. So what is the possible loop of me? So for I should be 1 to n, and what I'll do, if array of I is greater than array of I minus 1, not if it is less than array of I minus 1, array of I is less than array of I minus 1, just do nothing, just count plus plus, and at last if array of 0 is smaller than array of n minus 1, increase count. At the last day, if count is less equal to 1, return. If it is not, so let me do it. So int n equal to nums dot size for int I 0 not 0 1 I less than n I plus plus. If nums of I is less than nums of I minus 1, what I will do, count plus plus. What do you mean by count? Int count equal to 0, and after coming from here, if nums of 0 is less than nums of n minus 1, count plus plus, and at the last day, if count is less equal to 1, return. When count is less equal to, then return true, else return false. Yeah, it did go through. Just a second, let me take a bit of water. Alright folks, nice. Oh, I got a 0 millisecond time. By the way, I don't have an idea that how actually it is approach she got the idea, but it is really awesome idea. Okay, next one, remove duplicates from an sorted array. How to do it? See, when you got a name, remove duplicates, get unique from sorted stuff. What thing that comes in your mind? Please don't, oops, why I did everything previously. So to be honest, let me tell you, this account actually I did so many पहले मैंने बनाया था इस क्वेश्चन को. This is, if you see the submission, see, July 24, April 23, April 30, it's about a year ago, so that I'm just trying to practice it. Alright. Remove duplicates from sorted array. What do you mean by remove duplicates from a sorted array? Okay. What I see is the judge will test open the following code. That given, you see, there's the asset number. Sorry. So I have 1 1 2. I have 1 1 2. I'll return 2. Why? This is the index 2, or this is the length 2. What the length, or should return 2, the first two elements of them. Okay, it is 1 and 2, So for 0 1 2 3 4 0 1 2 3 4 4 5, okay, the length I have to return the length. So what I'll do is I'll put it in a sorted map, hash map, sorry, that is called a set, unordered set or unordered a normal set. Yes, it is sorted, so I will say a set. So let me do it. So there is a set int s. So for int I equal to 0, I less than n, I plus plus is dot insert nums of I. So int n equal to nums dot now what should I return? I return the last index. So for int I equal to 0, I less than n, not n, I don't know n, so should I do auto its I will do s of index equal to it and index plus plus and index equal to 0 and return index. Is this good? What do you mean by subscript operator? But I have written int I equal to 0. Why? Oops, sorry, my bad. What I'm doing, I'm increasing. So there is no issue with this. This should be nums of index is iterator. Why? See what I'm doing. I have 1 1 2, but the shade that I have built, that is 1 2. So I will do 0 0, replace it with this, and just don't do it anything. So I am doing this. Okay, replace and adding. Now it will run. Now this is the actual thing that comes in my mind, but oops, it is big of, what is the complexity? The complexity is big of n into, not it will be plus big of, if I consider big of n, so it will be big of n plus big of n, allegedly big of 2n space big O of n. Okay, is there any way to optimize this near about coming in big of n or reduce the space? Yes, can be. There is an way. What is the way? Okay, so in my book I have written this 1 1 2 2. Let me give an example like 3 3. What I've said is this is a pointer at I and j. If I equal to j, don't do anything. At first put I for sure in here, let's say 1. So if it is equal, don't do anything. So I will say j, are you equal, brother? Yes, I am equal. Okay, no problem at all. Then I will move this to this. And it will be here. So there will be one loop that will be iterating throughout it, and one loop is iterating checking key r2, are you here? Yes. Are you here? Yes. There is no, so just trace it like 1, like 2, like 3, return 3. It is pretty much absurd a bit. Let me do it. So int n equal to nonce to for int I equal to 1, I less than n, I plus plus, if a of I is equal to a of j, if a of I is equal to a of j, I will replace it. I will not create it. I will replace it automatically. A of I plus 1. A of I plus 1 will be replaced at A of I am iterating through it j. Make it j and not equal to, and obviously after that what I will do, I will increase the j by 1, sorry, I by 1. Int I equal to 0, and I will return what I will return, I, right? Let me try it out. It should run with ease. Oops, there is no A. See, this is the problem. Wrong answer. Oopsie. Oopsie. Yeah. Is there any optimal most? No, there is only. So what is the difference between that and that? Obviously this is only a big of n loop, and there is no space, so this is generally very good. So left rotate an array by one place. This is one of the nice problem that I actually got. One place, what will be rotated, what it would be. Okay, 1 2 3 4 5. If A is 5, okay, there is nothing to do with 1 2 3 4 5 2. Okay, understand. So I have 1 2 3 4 5. If I rotate it 1, so it will go here. So 2 3 4 5 and 1. So it's pretty easy. How to do it? So I will store the first, because there is one place, right? So just took a temp, choose array of 0 here and खिसकते जाओ इसको. I mean for 1 to n जो भी at array of I আছে, that would be array of I minus 1. So like this, array of I minus 1. Okay, like this probably. So int temp equal to array of 0 for int I equal to 1, I less than n, I plus plus. Array of I minus 1 will be array of I, and array of n minus 1 equal to temp return array. This is the first time we did it in the first chance. Phew. Crazy. Why the sound is not popping? Tung. Yeah. But the real trouble that comes in the D places, this left rotated array by D places, the 7th. The bad news is maybe today I will not be able to complete the whole 313. I'll probably do until 4, but yeah, we should be a bit fast. Okay, can we do it? Yes. Why I do it? Why I do it? So when I did it, actually again July, this month I actually started grinding. Okay, so I have 1 2 3 4 5 6 7. Okay, let me just do it. 1 2 3 4 5 6 7. Rotate it by 3 places. I'm getting 5 6 7 5 6 7 1 2 3 4 1 2 3 4. Understand the pattern. I am doing the 3. I am getting 3 from the left. This will be coming first, this will be coming last, and that's all. But the thing is, this should be done in brute force first. So the first theory is, how can this D be calculated or K be calculated? So let's assume the size is 7. What if I rotate this 7 places? I'll get this back. I'll get this back. First 3 4 5 6 7. So this will get back. So if the D modulo the size always be the D, isn't that true? So I can write D equal to D modulo N. Always, man. What do you mean by that? Let's say I will say ki art rotate it 8 places, so it will be 7 plus 1, so I will rotate 1 places. I will say rotate it 19 places. I will do what? Hello, 7 to a 14 and then 5. I will just do 5 rotation. So the first thing is clear. D equal to D modulo N. What is the second thing that I should understand in my mind? Okay, the first procedure is what I have saved. 1 2 3 4 5 6 7. By the way, is it left rotation or right rotation? It is right rotation. It is right rotation. My bad. It is right rotation, not left rotation. It is right rotation. This will be that rotation procedure. Okay, this is right rotation. What will happen? I will store 5 6 7 in an array. So I will have a temporary array. This will have 5 6 7. I'll say store it, nothing to do for you. Now what I will do here, one two three four. What is the return? 1 2 3 4 will be like this. So if I do 0 1 2 3 4 5 6, can I say the 0 will be one two three four? No, can I start from 4? Okay, So can I say the 4 will be the next 6? Most specifically, the 3 will be the next 6. The 2 will be the next 5. And I say the 1 will be the next 4, or 0 will be the next 3. What I'm doing actually, I'm starting from n, I'm starting from here, I'm placing them to what this can be said as, I don't know. What can I say better? If I consider n minus 1, 2k, this is k or d, and just I minus k or I minus d. So if I do the first thing, the first thing can be done to int k equal to k modulo n int I equal to 0, I goes to I plus plus, let's say temp dot push back nums of I vector int temp. Okay, so I have copied them. Now I have to start from for int I equal to n minus 1, I will go till k I minus minus, and nums of I minus k will be my new nums I. Okay, at last I'll reassemble the temporary. So for int I equal to 0, I less than n, I plus plus, nums I equal to temp of I. Can it be done? Can it be done? So that means key but temp of I equal to nums of not I nums of, again n is 3, so n minus, sorry, not n is 3, k equal to 3, n minus k plus 1, n minus k plus 1, sorry, I. This should be k. and this. Okay, my bad. I am reassembling, right? Set the size. So yeah, this is the way, but what I actually thought it the easiest one for me is this approach. What I will do is, okay, I'll get the n. Now the point is from where I will start to divide it. So 1 2 3 4 5 6 7, it will be like 5 6 7 5 6 7 1 2 3 4. I'll get a point n minus k. This is n minus k. I'll start n minus k to end get this here. This is my way. Okay, I will do rotate this. Okay, reverse dot begin comma nums dot begin plus n minus k and n equal to nums dot size then what I'm getting after this, I'm getting 4 3 2 1. And I am doing reverse nums dot begin plus n minus k comma nums dot end. I'm doing 7 6 5. If I reverse this, nums dot begin nums dot end ta-ta. Where is the fucking thing I'm happening? Oops, my bad. It should run now. Please brother, please, it should run now. Yeah. What is the complexity? a bit high, but the complexity gonna be. It is big of. Is it better than the previous approach? The previous approach I need big O, sorry, previous I cannot calculate that previous, that was big O of k. Let's me consider big O of k, big O of another k, and big O of n. So if I consider at the bad case big O of 3n, but for this case I am getting big O of n, big O of n, big O of n. If I am thinking this is actually wrong because I am dividing it. So this is big O of n plus big O of n to n with okay, that time I also don't use any space. So this is the approach. Nice. I did right. Now, as for example, I will not do it the brute stuff. I'll just do the optimal. Okay. So okay, what is given? 7, 5, 2, 11. Let me draw 7, 5, 2, 11, 243, 1, 1. The D is 2. Okay, what do in my 2? The resultant is 211, 243, 243, 1, 1, 7, 5. So D equal to 2 like this. After this 7 and 5 is coming. What's happening? I will store this. So vector int temp of k for int I 0 to k temp of I against for int I will start from D. I equal to k. I will go till n and I plus plus, and array of I minus D equal to array of I. As simple as that. And for int I equal to n minus D, I less than n, I plus plus, array of O equal to array of n minus k, sorry, n minus, not D, holy shit, I am writing D, k, n minus k plus I, right? Okay, no, sorry, n minus D. And return. oops, I plus, not necessarily maybe I minus. Again, why? It did go through. This is the problem and this is the solution. So can we do the previous one, by the way? A temp of I minus n minus k. This. What is the complexity? The complexity is big of 3n. If I consider big of 3, that is wrong. Big of d, so big of k plus big of k, and if this is big of x and this is big of k, this is should be x minus k, so big of n minus k. If I do big of k plus n minus k plus k, k gaya, k plus n, big of n will be space, this is will be time, big of not n, sorry, big of k, where k is the stuff that in my resultant vector. No, how can I do it? How to do it in universal, right? So see, I actually get it. How? If I reverse the whole, what I'll get? 1 1. No 7 5 5 7 7 5. Okay, what if I reverse this? I'll get 5 7. Reverse this whole 1 1 43 11 2. Reverse the whole. I'll get it 2 11 43 2 11 40. Okay, how to do it? Reverse int n equal to array dot size, reverse array dot begin to array dot end, not array dot begin plus k, then array dot begin reverse array dot begin plus k comma array dot end reverse array dot begin array dot end return array. Yeah, it go through. Nice. Awesome. Alright, so this is done. The 9. Probably I'll do 9 and 10, and the rests will be done in the next. Okay. So move zeros to the end. Who's a brute? Zero 1 0 3 2 0. It will be returned as 1 3 2 0 0 0. What I'll do is, the easiest way that I can see is get the non-zero elements. If the array, let's say I'll get an array that have the non-zero elements and replace this, and the rest will be replaced as 0. As simple as that. Is there any brute? Let me see. Yeah, there is brute. This is actually the brute that I have said. I'll create a temporary array and store the non-zero element. That's probably the most easiest idea. So vec end non-zero element int for int I equal to 0, I less than n, I plus plus. If nums of I is not equal to 0, temp dot push back nums of I. Nice. Then just copy in temp everything, like for int I equal to 0, I less than n, I plus plus, and do what? Do nothing, just nums of I temp of I, and create a for loop equal to temp dot size. I have replaced 1, I have replaced 3, I have replaced 2. This is temp dot size 2i less than n I plus plus nums of I equal to 0, nums of I will be changed to 0, and probably this is all we have to do. Oops, I'll get a bug that there is no n, so int n equal to nums dot size probably. Oops, my bad. Yeah, let's do it temp. You can see oops, this is temp dot size because I am going from 0 to the temp dot size. Yeah. It is 3 millisecond time. So what is the complexity? The complexity is big of the same, big of 2n apparently, and the space is big of n. But what will be the optimal approach? So 0 1 0 3 2 0 0 1 0 3 2 0. I'll take a point at I and I'll take a point at j. I'll say if I is 0, what a place, so it will be 1 0 0 3 2 0. Now this is I, this is j, j is 0. Okay, do a place, so 1 3 0 0 2 0. J is here, j moves to this, I is still here. No brother. Okay, yes brother. 1 3 2 0 0 0, both are 0. This is, there will be 2-pointed approach, pretty easy. So int n nums dot size for int I equal to 0, I less than n, I plus plus. Okay, understand this. If nums of I is equal to 0, if nums of I equal to 0, move j equal to I, j equal to I, both in the same, and break. If int j equal to -1 or int b. Okay, okay. If j equal to -1, return or break, or I will return probably. Now I'll go j plus 1 to n. if array nums of I is not equal to 0, then swap nums of I nums of j and j plus plus. A bit tricky this code is, but yeah, this is just big of just to -1. Does it? Yeah. Sometimes it gave. Okay, so this is big of n. This is big of n. So, but this is n minus x. Big of x. Sorry, big of 2n. Apparently, if I see that is big of 2n, but yeah, and space is big of 1. All right. The next question. Linear search. This is easy and we can do it in a second. So basically 1 2 3 4 5 6. So it's saying key, let's say 1 2 3 4 5 6. It is giving a target 6. I don't say that 6 is inside of the array or not, so I will do it. Are you equal to 6? No, brother. Are you equal to? No, brother. Are you equal to? No. Are you? No. Are you? No. Are you? Yes. Return true. So generally it is pretty easy. So for I will get int n equal to array dot size. For int I equal to 0, I less than n I plus plus. If array of I is equal to k, return true. If it is doesn't, return nice. It did go through. So yeah, for today this is the all. I have done 10 problems. Probably kal I will upload a video or I will do a live short live that will be only consistent in 1 2 3 4 5 6 7 problems, but to be honest these problems are a bit different, so we will do it for sure. Though the union is a bit easy, means the brute process that comes in my mind that easy. That's all. I think that's all for today. This is 2:25 minutes. Goodbye guys, and yeah, you guys can check this out. This is a pretty cool thing. Yeah, we can do one thing. See, I know some problems I have to just see a bit the solutions a bit. I have to get a bit of idea. What we'll do is, let's say should I have completed array, easy. I have did a live where I have solved this. Kal I will do array medium. Someday I will do live and practice those. Someday I will do array hard. I will do a live and probably practice this. again one day when I'll get a big maybe weekend, then I will do very easy, medium, hard. Probably there will be more than, how many problem is there? Let me see. I am taking to take you forward to for, but maybe not less than, maybe assumption not less than 100, not more than 100, because if I divide 20 into 3, that is 60, but yeah, so 100, let's say 100 problems, right? I will solve 100 problems in one go. Then I will divide it. Maybe in college I will do it, maybe someday जितना प्रॉब्लम हो सके कर लूँगा. उसके बाद I will do it in the next day maybe. Well, that will be the best thing to do. And after everything, after completion of everything, I will do Codeforces contests and I'll maybe practice it. Maybe that is a good idea to do it. So thank you guys for watching this video. See you probably in the next time.